Hi guys, welcome to this lecture, and it's a crash course on Docker, right? Because of the fact our entire project stack is built upon the Docker, right, using containers. So now let's quickly understand the fundamentals of Dockers. Why are we using it, and what are Dockers, and how it works internally and from the command perspective and from the compose perspective, from the deployment perspective, how Docker fits into the picture, right? So now let's quickly begin with the question that how does this world of deployment looks like if we are not using containers, right? We already spoken about few of the problems earlier in the earlier lectures, but at this lecture let's try to understand the important problems that we have, right? One problem is the dependency management manually, right? So you have application code, and before deploying application code to any of the environment, what you need to, or DevOps team needs to do, is to deploy all the dependencies. For example, if you have a Python code, then you will have to deploy the Python, right? And some kind of other SDKs, whatever you are using as part of this application stack. Or let's say you are using Java and you are building your application microservice on the Spring Boot framework, then you need to the JDK first, because that's on the Spring Boot Java application works, and then there are other SDKs and other dependency libraries that you need as part of the environment. So all point is the all dependencies needs to go in before the deployment of actual application code, and then this everything needs to be managed manually, right? So that's the problem, the bottleneck we have. Now second problem we have is the conflicts in the dependencies. So for example, you have a project, then there was a legacy service you are using, and that legacy service is using JDK 8, right? You may be built in into 2008, 2010, or let's say some year under 2016. But now there was a new development work that came in. You developed a new service. Now as per the technical upgrade of your organization, you are not using JDK 8 anymore. You have started using JDK 17. So now this application, this newly developed application uses JDK 17. However, the existing legacy applications are still using JDK 8. Now again, it's a problem of dependency conflicts, right? So in the environment, you have JDK 8 and then you have JDK 17. Now how will you manage in the same environment? You can't have something like, for example, you will deploy JDK 7, JDK 8, 17. Maybe you will find some way of doing so, right? But it will again cause a lot of issues. Everything needs to be manages manually, right? So that's the another problem. Third problem you have is the difficult scaling. For example, today you have a load of 15,000 users per month. Maybe tomorrow you have 1 lakh, and then the day after tomorrow you have 15 lakh. We don't know, right? There could be different user base, dynamically can keep on increasing, can keep on decreasing based on the requirement and the time constraint, right? But the point is, if I want to scale my application to the more number of applications and instances running it, I can't do it very easily. There will be some manual intervention involved, right? So these are few problems. You see, I need a concrete solution to get rid of these three important problems at least. So I don't have to manage the dependencies manually, and then I don't have to have the conflicts between the dependencies, and also the scaling of application for me at least should be easy. So these are the places where the containerization comes in, right? And then this makes your life easier. So as a container, no matter in which operating system environment you are running in your application, you just have to ship your container, your Docker image, and then you will be able to run your application very easily, right? Also, if you're looking at the world, right, today's business perspective, there are a lot of changes. Everything is agile, has become agile. Everybody is following agile sprint, right? The Scrum model of 10 days. Now the problem is we have continuous planning, right? We have continuous development, we have continuous deployment, we have continuous feedback. Everything is continuous, right? You plan for any business value to develop anything, then you do the development on it, then you will have to deliver those value into production. So you start deploying these, right? And then there is a problem from users, the BA and the other stakeholders, you again have to plan to adopt to those changes, those new feedback, and then again do the development, again do the deployment. So everything is continuous in the iteration, right? So in the fast economy, in the fast business world, how can we get rid of these manual interventions? So this is where the solution comes in, which is your Docker containers. Basically the solution is containers, but the fact is Docker is popular while we talk about containers in the market. So that is why we have started using Docker containers, right? So now let's quickly understand the architecture of Docker, that how it actually works, right? Maybe it's not relevant to all of you, right? But at least from a 10,000 feet level, it's important to understand how Docker architecture looks like, right? So there are three major components. One is client, and second is Docker host, third is registry. So client, when I say, this is the interface that talks to your Docker host. So Docker host contains multiple things. It contains your Docker daemon. So daemon is, you can assume this guy as an engine. This is the heart and soul of entire Docker architecture, right? Then you have images, then we have containers, then we have registry, images, etc., plugins, etc., right? We will understand in the next slides what is registry, images, containers, and all these things, right? So now client interacts with the Docker engine, which is your Docker daemon, and then Docker daemon make uses of all the images and then convert them to the Docker containers. Eventually the output product you have in the containers running in your environment, and then these containers are built upon using images. These images are stored into your registries, right? Now from registry, your Docker engine fetches all these Docker images and then populates your Docker container right here, right? So at the 5,000, 10,000 feet level, this is how a Docker internally looks like. So these are the commands that you use. These are the important one are these, and there are other commands as well. So these commands are used to interact with the Docker engine. So Docker is itself work on the client server architecture, right? So it's a client for you, and this Docker host and this Docker engine, the Docker daemon inside it, acts like a server. So when you run a Docker run, or you run any command like docker build, docker pull, all these commands are kind of sending a request to your Docker engine. Now Docker engine looks at this command and see, hey, this is what I have to run, and accordingly it starts executing all the process flows, right? So that's how it works at the high level. Now internally, if you see, as I said, it's a client server architecture, and then there are several things. So now let's quickly go one by one. So which is client? Now client enable users to interact with the Docker. For example, this is, let's say you have an airport and then you have a counter, right? So if you need to buy a ticket, you first go to counter, then buy a ticket. Then maybe where the person at the counter level do some kind of operation into the software applications, right? Maybe go beyond that and do something else. So those kind of thing. But if you look at, assume the counter looks like as a client to you, right? Because you only speak to counter people, and then these are the guys that does everything on your behalf, right? Now Docker Compose is another client. We will see that what is Docker Compose, right? Just leave this term as it is for now. Docker daemon is kind of an engine, as I already explained. It build, run Docker containers. It manages the entire life cycle of Docker containers, every single thing about Docker containers, right? Now then you have registry. Registry stores your Docker images. We will quickly understand that what are Docker images. All right. Then you have the Docker client, and as I said, the Docker client and daemon, these two guys, right? These two guys talk to each other via REST API. So when you run a command, maybe there is some kind of a command gets invokes right here, or maybe some kind of API gets executed, and then it starts processing, invokes a different flow on it, right? So now then you have the Docker desktop. So now what is Docker desktop? Now you, as a user of Docker, right, before directly deploying into production environment, or let's say in any environment, what you need is to create Dockers into your local computer, right? You want to test few things as Docker. You want to pull images from the Docker hub. Now all these things you want to do as part of your the Docker. Now, this is where the Docker desktop comes in. The software, the application that you install in your local computer is the Docker desktop application, right? As I said, it's easy to install application on your Mac, Windows, and Linux. In any of the operating system, you can install Docker desktop, right? So as I said, it enables you to build, share containerized applications and microservices. So microservices, when I say the applications, right? So using Docker desktop, it allows you at your local computer to build and maintain the containerized applications, right? So Docker desktop includes Docker daemon. So when you install Docker desktop, so as part of the Docker desktop, this whole architecture comes in. This whole architecture gets deployed into your local computer. This is what I have explained here. So when you install Docker desktop, it includes the Docker daemon, the Docker engine, and the Docker client, and the Docker compose. All right. Now, how does this Docker desktop looks like? So this is how your Docker desktop looks like. Like you see, this is the Docker desktop, right? And then this is the account that I'm using here. When you will start using it, you will see an option like this here. So here you will see a lot of extensions, the plugins. Then you can also install the Kubernetes right here, right? And then you can see the about version. For example, I'm using this version of Docker desktop, and you can for yourself download one Docker desktop. For example, if you want to go in the Docker Hub, you will see you can, in the home page itself, this is the front home page, you will see it asks you to download the Docker application, and then each on different based on your operating system, you will get an option to download it, right? So if you want to download the Docker desktop application in your local computer, go to hub.docker.com. All right, now very simple. Now this is how your Docker desktop looks like. Now let's quickly move on and understand your Docker registry, right? So Docker registry comes right here, this interface. Now Docker registry, it stores your Docker images. Now the question is, what are Docker images, right? Very interesting. We'll see that. Hold on for some time. Now simply understand it. It stores something related to Docker, and then those are Docker images, right? Images, basically Docker images contain some set of instructions to create a Docker container. We will understand that in depth in the later sections. Now it stores your Docker images, and then for example, I just in the browser, in this browser, you can see that you have hub.docker.com. This is nothing but a Docker registry, right? A public registry for Docker. So this, if you see, this is available to everyone. Everyone in the world can directly access it by going into this URL on the internet, right? So it's a public registry for Docker. So any Docker containers can be published here and can be downloaded from here. So once you install the Docker desktop in your application, right, then you need to do a sign in by going here. For example, if you see here, if I would have not logged in, then this would have been showing me the login button. Then by click on it, I have to use my hub.docker.com username and password credentials. For example, I have this Uchet12 username to log in into Docker Hub. Then the same thing you will have to do in order to register. So first you will have to register into the Docker Hub, then you can log in using same credentials into your Docker desktop. So you will start seeing these account name right here, right? So once you have that access, what does this mean look like? So this means that you can start pulling the images from Docker Hub and then start pushing images to the Docker Hub, right? For example, if you go to Postgres, you will see this is the official image of Postgres database. If you want to use Postgres into Docker containers, then you can simply go to Postgres official image. Then here you will see a lot of text, right? If you go here, you will see a lot of text. Now these text varies in terms of the total memory it's taking and the dependency on which the Postgres is dependent on. Now based on your requirement, you can pick one, right? For example, I can use this 14 Alpine version, this 14 Alpine version, right? Whatever. The point is, if you click on it, for example, if I click on it 15 Alpine, then you will see that I can pull this Docker 15 and if you go and then you will see these are the commands, right? These are the different commands using which this alpine image has been built upon. If you go back, then you will see on the right hand side there is a command to pull these Docker images on your local computer. So for example, if I go here and then if I want to pull one image, and then if I say, let's say this, since I'm logged in, right, you can see I'm already logged in Docker desktop using my hub credentials, so I don't have to log in. It will automatically start downloading the Docker image from the Docker hub, right? And then we'll take it and we'll store it in my local computer. All right, so that is how you can pull images from your Docker hub account using Docker desktop. All right, now let's quickly move on. And then as I said, it's a public registry, right? Whenever you run for something, right, for example, if you want to download the Postgres, by default it always start trying to pull the image from the Docker hub, right? That's how it works. But if you think from the enterprise perspective, let's say I am working for an organization XYZ. Now you are building your custom images. Now you have an application, let's say order service, right? That order service has many REST APIs that fulfills the business value of maintaining and creating orders. Then now in order to, and I want to run that Docker service as a containers in my Kubernetes environment, or let's say any environment, then the question comes in, will I be using Docker Hub as a registry to store all these Docker service images, right? So that's the question. Answer is no, because these organization has private registries, right? Because for example, Docker Hub is a public registry. It doesn't mean you cannot have another registry. You could always have one. For example, many organizations have their private registry. If you are using Azure, AWS, any of the other cloud provider, or any of the cloud provider, you can create your own container registry, and as part of your CI/CD, as part of your build release pipeline, you can always create the build Docker images and store it to your private registry, right? That is why I mentioned that we can use private registry as well, for example in Azure, AWS, and etc. All right, so now let's move on to Docker objects and quickly understand what is Docker image, what is Docker container. Okay, so before understanding Docker images and the Docker containers, because we have been going through a lot of theory section, I understand that maybe if you are a fresher and if you are someone who is beginner and not able to connect the dots, that's totally okay. Let's move on and try to do some kind of practicals and play around with the Docker containers and images, so you will get a fair idea that what I'm trying to understand. Then you will always try to connect the dots, right? And you will get an idea, visualize, okay, how does it looks like and how these things work, right? So now what I'll do, for example, I have one application which is my invoice service application. Okay, so now I have prepared this Docker desktop. Now this is my invoice service application. It's a Spring Boot application. If you are not aware of Spring Boot, that's totally okay. Understand that this invoice application is kind of a Java application and I'm based on the Gradle, right? And it's a Spring Boot application. Now if you go to this main section and the resources section, you will see that I am trying to connect this application on Postgres, right? And then on this database, statistics database, and then using this username and the password. So that means this invoice service application basically integrates with the database. Whenever it gets up, it tries to create a connection, establish a connection with the database and try to pull the data from here and there, right? Perform some kind of database migrations, create table, and then insert some of the data into the table, and then connect with the data. And based on the API you hit, it also has some APIs. If you go to invoice controller, you will see it has this API, the V1 invoices API. It's a get API. If you passes as user ID, it will give you the user data based on the ID. So I have already created dummy invoice data into the database, right? So whenever this application will get up, it will try to connect itself with the Postgres database in my local computer at port number 5432, and then based on the user ID, it will fetch the user data and then invoice data based on the user ID and send you as a response, right? So it contains a REST API. All right, now since it's totally depend on the Postgres database, what we need is to create the Postgres database into the Docker as a Docker container, right? Now, in order to do so, we first have to download a Postgres image, right? So by going into Docker Hub directly, you can download one image. I already shown you, right? First, if you go back, so we will use we will use this version of Docker, the Postgres Docker image. So tag is nothing but it indicates a kind of a version, right? So this tag has 16 Alpine 3.2.0. So if I want to pull this image, what I need to do is simply to copy this, and if I go back and I can click, and then it will soon itself. So it says that pulling from library progress. So I already have the Docker image, so it did not went back to the Docker Hub and did not downloaded it again. So it said, okay, you already have Docker, this Postgres Docker image, so I will not download you for one. But if I go and, for example, download this image, right? If I copy this and go and download this, it will simply download this because I do not have this image. So if you go here and go to images on the Docker desktop, you will see the remote repositories. All right, if you don't go here and then go to click on Docker images and you say Postgres, you see I already have these three Postgres images, but has different versions, the different tags, right? You see this Postgres image has 16 Alpine, it has 14 Alpine, and this is some kind of a latest image, whatever the latest. And each image varies in terms of the memory. You see, this one is taking around 250 MB memory, it's less than 250, and it's way more than 400, right? Now you see, since this was not present right here, it was not present, so it downloaded this image again from the Docker Hub using my credentials, right? Now if you go back and again hit it enter, now it's not 3, you can see 4 instances of images, right? This was the one that I downloaded recently. It's again of size 250 around MB, right? So now, and Docker login is the command using which you can log into your Docker desktop from the command perspective, from the CLI command perspective, right? For example, it says login succeeded because this already has my credentials. It says authenticating with existing credentials. All right. So now let's quickly go back and then run a Docker container for Postgres, right? So, and then try to up the Postgres database, and then we will try to deploy this our invoice service API into database, as a Docker container, and these two services will talk to each other. All right, very basic. We will simply use the commands, and all those commands we will keep on executing. I'll keep on explaining you together. All these things we will do together. All right. So now, in order to run this, I'll say, now I want to create, I already have the image, right? So if you go to Docker images and then you say Postgres, right? So you will see Postgres, then you will see I already have this 16 Alpine image right here. So now I want to deploy this Postgres Docker image as a container, right? So before deployment, let's quickly see how the workflow looks like. It's very simple, right? So if you go back to the presentation and then you go here, so you already have a Docker image. We already have a Docker image. Forget about this left hand side part. We already have a Docker image. I want to create a Docker container out of it, right? So whenever you use a Docker run command, you can simply use the Docker image in order to create a Docker container. Very simple. So, but the moment you will run the Docker run command, you should have, it will go to public registry. It will first check in your local computer and will see if you have that image, the image you are trying to run, right? If that is present in a local computer, it will simply start running your Docker container. And now, in the use case, if it does not have, if your local computer does not have that particular Docker image you're trying to run, then it will go to public registry, which is Docker Hub. Using your credentials, will try to pull it to your local computer and then will run it as a Docker container, right? Now, since if you see here, we already pulled one Docker image, right, here if you see, we already pulled one Docker image, so we don't have to again pull it, right? So we can simply go and directly start running it to create a Docker container. Now since I want to use this 16 alpine 3.2, then I will simply use the command to run it, right? Now if you go to the architecture, you see there is a docker run command that we can use in order to create the containers right here, right? So using docker run command, we can send the command to the engine. It will say, oh hey, can you create me a docker container for this particular docker image? So it will talk to the registry and will try to get the image. All right, so now I'll go back to the command and I'll say docker run, right? This is the command. Now so whenever I'll create a container, I want to name that container, right? So what would be the name of my docker container? So I will say, for example, Postgres DB, right? Now I'm saying whenever you run a docker container, I want to expose a port, right? So whenever you run a docker container, so whenever you deploy a docker container, something looks like this. For example, you have this blue area as your docker because you install docker desktop, so you have this docker, and then this green area you have as an operating system, which is also known as host. So whenever you run your Postgres database, it will looks like this white box, right? It will be your Postgres database. Now you need to tell on which port number in the docker desktop this container will start listening to. So whenever a request comes into this port number 5432, so this request will be served by Postgres DB container inside the Docker, right? This is what it indicates. So in order to tell this, right, to Docker, we will have to expose the port. We will have to tell, okay, this is the port number I want to expose, I want to open, right? This is why we first need to pass the command of, you can say, the expose the port, right? So how can we say that? So you need to say by using p. Now using p, you need to define the port number. So you're saying, okay, open port number 5432 from the container to the host, and then you have to simply pass the image name. Now what is the image name? Your image name is Postgres. You can also go here and get the image name is Postgres, right? So I'll set Postgres, and then you can use the 16 alpine. So now you can do a colon and then this, right? Now there is another point. When I'll do so, this Postgres database will start running, right? So now let's try to run this. You see, now there is some error. You can see it says Postgres database is already running, maybe because I was trying to play around it earlier. So I'll simply put it off, and then we'll run this container again. So now, so we already understood from the integration perspective, from a high level perspective, that how it looks like from here, right? It has the host and the Docker and the container running right here. And we also understood that we will have to expose a port number. So what I'll need to do is, now we will have to run the Docker command in order to create up our Docker container using the Postgres image, right? So we already have few images, as I said earlier. So I'll say Docker image is, and then I'll say Postgres, right? So now we will use the 16 alpine 3.0. So I'll have to say Docker run. Now we will need to name the Docker container. So when it will run, with which name, what will be the name of that Docker container? So I'll say Postgres DB. All right. Now I will have to expose the port, as I already explained you. So I'll say expose the port 5432 of container to the host, and then you simply refer to this image of 16 alpine, and then I'll say 3.2.0. All right. So when I'll start running, you will see an issue, right? What that issue will be, you'll see that. Okay, now it said, okay, you want to run this image as a Docker container, but you can't. There is a must have. There is a prerequisite. What is that prerequisite? Because it's a Postgres database, so it's asking me to set a password, right? So the way Docker container works is, whenever you up your Docker container, and whatever properties you use, let's say there is Postgres itself is an application. Maybe somebody has created Postgres application in C++, right? The point is this Docker, this Postgres itself is an application. Maybe if you look at the invoice service I have right here, this is also nothing but the application, right? And this application also has a lot of properties, right? So whenever you create a Docker container, for example, if after some time when I will be running this invoice service as a Docker container, Docker simply treats all these properties as an environment variable. So even if you want to override these values, you can always override these values. All right. So now I want to set a password into Postgres database. How can you do so? So I already have the Docker run command. So I'll simply now we'll say it's asking me to use -e. -e is for environment variables, right? So now I will have to -e. I'll say -e, and then I'll say here, I'll simply copy this, and then I'll say test 1 2 3. Okay, so this is done. But now what I need to do is whenever this container runs, right? There are another entities, another kind of a Docker object that we call the Docker network, right? So Docker network is same as the network today you have. The network is an entity that with which any application gets attached to, right? And when you attach to a network, you always get certain kind of IP addresses, right? So now why are we using network? To attach things, to attach applications together. So even if you look at the computer labs, right, in the college, in the offices, you have every computer connected to the network, right? So each application, each computer can talk to each other and share data in some form, right? The same way, if you want to let Docker containers talk to each other, you need to have a Docker network, right? Now the point is, how can you create a Docker network? It's very simple, and it's the same command, right? All you need to run is Docker network and create, and I'll say the DB app network, right? So when I'll click, it says okay, DB network, and then I can see command. Now if I say Docker network, Docker network ls, so you'll see there are many networks, right? And here if you see, I have this network ID created, right? It's a Docker network. All right, so now what I want, whenever I deploy this Docker container, I want to deploy this on my DB app networks. How can I do so? First, I will have to pass my password. So I'll say postgrace_password, and then I will have to pass my passwords. So let's say I'm keeping my password as test 1 2 3. So now I will have to pass my network. So how can I pass my network? I'll say Docker network, and then here I will say, what was my network? Docker network ls DB app network, right? That was my network. So I'll say the spelling is incorrect, which is okay, and then I'll simply run it. So it says DB Docker is already in use because we tried running it but it failed, right? So I first need to remove. So I'll say Postgres DB, right? Okay, so now I'll run this again. Okay, so now it's running. Okay, now you see my Docker container for Postgres is ready, right? So this guy is ready. If you go to if you go to the image, you'll see this guy is ready, right? Now what I want is, I want another guy, and then this would be my invoice app. I want my invoice app to connect with the Postgres database, right? Because that's a part of our business logic. All right. Now, and that is the reason I created a Docker network, right? Because I want these two guys to talk to each other in terms of technically inside Docker. Now these two are connected with the Docker. So you can say, you can create, you can try to visualize something like this. I'll say this, and then I'll say this. So this, you can call it as a Docker network, right? Network. Okay. All right. So now you can I'll say red. So this red piece is a Docker network. So all these two containers will be deployed using Docker network, right? So now this is connected to network. This is connected to network. So now these two can talk to each other. They're eligible. So if I don't have this, then what will happen? Now invoice app cannot talk to Postgres database, right? So but in order to connect these two things together, we will have to have a Docker network, and that's where these two applications has to attach themselves with the Docker network. All right. So now if you go back here, and then you see, if I say Docker container PS and then Postgres DB, then you will see this container is running, right? And then port number 5432 with the name Postgres database. All right. So now here, I want to see the details of this container. How can I do so? I'll say you can use a command docker inspect, and then you can simply copy this and paste it here. So I'll say docker, not container, only spec is enough. Inspect docker container inspect. All right, you see, so now you can see this is the same network ID, right? It has, the network is the DB app network, and then you can see it has own IP address. So you can see there are a lot of things, right? There are a lot of things. If you can see that this port number is, this is exposed, right? You can see that it has a port number, right? And at the local host, it will be exposed on port number 5432 on TCP, right? Now you can get a lot many details right here, right? Now we will not go into this much of depth, otherwise this much of depth, otherwise this won't be a crash course. We will have to make a full-fledged in-depth course, right? Now let's quickly move on and try to deploy the invoice apps as well, right? So now if you go right here, this is already running. Now let's go to my dbeaver, and then we'll try to connect this. I'll say disconnect, and I'll go to Postgres database, right? So the database, let's say, is Postgres, and then username is Postgres, and the password I said test123. Okay, so I'll say test123, right? And it's running in my local host. When I say it's not running in my local, it's running in container, but in the Docker, but I have exposed the port number 5432. So anyone from the host, which is my operating system, because I'm accessing this from my operating system, if anyone tries to access 5432, all these requests will be rerouted to the Postgres database container, right? So if you click on test connection, you will see it's connected, right? So now I'll go to Postgres. We don't have to. I'll simply click finish, and I'll go to edit connection, and then I'll give this guy a name, a simple name. Let's say invoice app database. All right, I'll say make it simple, Docker demo database. All right, so now I'll say okay, I'll make this ready. So now this is ready, right? Now let's quickly go ahead and try deploying the invoice app. So if you look here, right, this application of mine, this invoice service, is accessing Postgres database. So this is the database container name. I have already given this, and then port number 5432. You already aware of this, and you look here. This is the database name I want to access to. So we don't have this database as of now created. So what I need to do is create this database, right? So I have Citrix database. So I'll Citrix DB. So I'll make this as a default, right? And then I will go to my screen again, and then I'll say Docker images. I already have the invoice app, and then, or better, right, let's create a Docker image of this, and then we will try to deploy this. All right, now if you go back to the presentation, you will see that I explained you something like this. So for Postgres database, the approach we followed was to pull a image, right, from this Docker registry to my local, and from image we use the run command in order to create a Docker container. Now for this invoice service, because this is a custom application, this is not present in the Docker registry, what I need to do is, using this app, I need to create a Docker image manually, right? Now how can I create a Docker image? Now there are few provisions to create Docker image. For example, I can create Docker image using Docker files, right? So that is something which is covered already in depth as part of this course, but you can understand that using Docker file I already have created it. So now don't go into the depth of how I created Docker file for this Spring Boot invoice service application. We will see that as part of this course. I have already explained that in the later lectures in depth. Just understand that we already have a Docker image of invoice app, right? So if you see here, I already have multiple images with multiple tags for invoice app. Now this is the recent one, right? If you see incrementally tags and keep on increasing, then invoice app 4.0 is the latest one, right? Now what I want is to run this, and then I want, once I run this using Docker run command, this image of invoice app, this will start running as a container, right? So now that's how these two containers can talk to each other eventually, right? That's how I can try accessing this invoice app on port number, this will be running on port number 7002, and then once the Docker container will get up, my Spring Boot container will also get up, and then it will start fetching data from the Postgres database. So now I can test the REST API in order to validate if invoice app can go to database and try fetching my record that I need or not, right? So I'll say here, and then I will have to run the commands, right? How can I run the command? It's very simple. I'll say, so this is already running. My database is already running. You can see database on the Postgres Docker demo database on the Docker container is already running. What I need is to run the invoice app service, right? How can I do so? I'll say Docker run, or let's say Docker images, Docker, not Docker, invoice app, invoice app, right? So I'll say, I'll enter, I'll say Docker run. Now I want to name this as name. What would be this container name for my invoice service? I'll say invoice app v2. Okay, version 2. And then I want to expose the port. I want whoever wants to access the APIs of this service can talk to port number 7002. 7002, right? So as part of the Spring application, you also need to define this. For example, in my Spring Boot application, I have defined server port 7002. All right. So now this is done. What I need is we have already exposed the port. Now, if you remember, the important fundamental concept is, if you want to let this invoice app talk to the database, this also needs to have on a Docker network. This needs to attach itself on the Docker network. So how can I do so? So we simply did the same way we did it for this container, right? And you see, we passed hyphen, and then we passed the network name. The same thing we can do so. We'll say network, and then my network name is app. Spelling was different. I'll say, what was the spelling? I don't remember. I'll go here. This is the details of this DB app network, right? So I'll copy this, and you can also see in the environment variable, right? It has the database password, right? So I'll go here, and then I'll pass this here. Okay, now this is okay. Which image I want to use? I want to use this invoice app image. So I'll copy this, and then I will say, what would the tag number? 4.0. So I'll say 4.0. Okay, that is it. That's how we ran the other Docker container of Postgres. That's how we can run this one, right? So I'll simply click, and then you see Once the Docker container is getting up, my Spring container is also trying to get up. Now you see these are the logs, right? These are the logs. Now you see it's trying to create, it's connected with the database and it migrated, it did some changes, successfully applied 2 migrations, right? That means it did some changes in the database, and then it says Tomcat started, right? That's what it said, and then this is the database it's using, right? It said this is the same database which is running right here, correct? Now if you go here and then you'll say the Docker container ps, then you'll say Docker, I'll say invoice. You see this invoice is running, this is the container, right? Even if you go to Docker desktop, right, here in the container section you will see that Docker, where is it, invoice, I'll say invoice app, you'll see this is running, right? Invoice app, this invoice app v2, so it's on green state. You see, you can also see from, as you can see the everything from the terminal as well as from the Docker desktop as well, right? So any approach, you see these are the logs you can see, right? The same logs that you can see from right here. All right, now if you try inspecting this, and you say Docker container inspect this, and if you hit enter, you'll see on the network settings it's also connected on the it exposed on the port number 7002, all the requests it's listening on 7002, and then the network section you can see it's using the same network. That means the diagram we created here, these two containers are now attached to the Docker network. Right now, that was the reason it successfully ran, right? Otherwise there would have been some errors. It would say that it's not able to connect with the database. All right, now if you go up, then interestingly you will see that in the environment section we have these as the environment variable. Right now, if what I want is, I want to run some of the API of invoice service. So that's how I can validate that my API is successfully running or not, right? So I'll say this is my API which is running in port number 7002, right? If you go to my application, so if you go to controller, you'll see v1 invoices, this is the API, and it's a get API. It takes user ID, and then user ID you can take any user ID from this section, from second column. This is the user ID, right? So if I copy this and then if I pass this here I hit enter, you'll see I'm getting data 200, right? If you see 200 I'm getting for every time I'm hitting this request. All right, and then you can see the logs here as well. Received request for user ID this, received request for returning invoice response, right? So if I keep on hitting this API, you'll keep on seeing you'll keep on seeing a lot of data right here. See, you can see a lot of data, right? I'm keep on hitting, I'll keep on seeing. So that means all the requests are being rerouted to right here, right? So if someone from the host, from the operating system green area is hitting on the port number 7002, now because of the fact this container is listening on 7002, all the requests from the host are being rerouted to the invoice app. So now when you are passing a request for the API on 7002, as part of the business logic, it's connected to Postgres and trying to fetch the data for user ID and send it back to the whoever the consumer at the host level, right? So that's how the whole everything is working, right? Now there are few things you could do, right? If I shut down this and if I shut down this, now if I want to run the Postgres is in the detached mode. So what is detached mode now? So you can see the moment I did the control C, my Docker container stopped, right? But now let's say if I want to run my Docker container as, I'll first remove the first one, I'll say okay. Now I'll simply run this in the detached mode. So I'll say don't get synced with the terminal. The moment you cut it down, stopped it from the terminal, your container gets stopped. I want to run it as a detached mode, right? You don't see any logs here. You don't see any of the logs here. But if you go to container ps, we'll say Postgres. So you see, you have this container running, right? But I want to see the logs. How can I see the logs? One is you can run the command container logs, and then you can print this, right? You can see all the logs right here. Second way is you go to Docker desktop, right? And then you look for your container, and then go to that particular containers logs, and then if you go to Postgres, you see inside the Postgres DB you can go to logs and you can see, look through all the logs. You can go inside it, right? You can see this is the Postgres password as an environment variable we injected, right? So now that's the very basics of Docker desktop. Now let's quickly go back to the Docker presentation. So this is what we did. So maybe now by this time I'm sure you could visualize that what is Docker images, right? So if you go to Postgres, then if you go to invoice app, these are your images looks like, right? So for Postgres, because Postgres was a generic application, it pulled it from the Docker hub. Invoice app, it was my custom application, so I created in my local. It's still in my local. If I want this application to get it to the Docker hub, so I will have to publish it, right? I can simply publish it because I'm already logged in my local using my Docker hub credentials. All right, so now using it, we created Docker image, we ran it as a Docker container and took it everything from the Docker registry. So by this time we explained everything, right? Now the last topic comes, which is your Docker compose, right? Now here if you see, right, the important thing you see, I was running the Postgres as a separate command, right? Using this command separately, I was running the Docker container for Postgres, and then separately I was running for the invoice application, right? Now the problem is, every time I want to create a Docker container, I will have to run this command again and again. Second thing, let's say I want to deploy 4 or 5 applications together along with the Postgres, Elasticsearch, Logstash, and many of the other applications, right? This running these commands manually will become a kind of a very manual thing, boring and very difficult to perform, right? And it's a time taking, not an efficient way of doing so. So this is where your Docker Compose comes in, right? So it's a tool that helps you to define and share multi-container applications. So in a file, you define that these are all the images I want to run as a Docker container. So the moment you run using a single command, you don't run the container separately. You don't run on the images separately. You simply do a command Docker compose, and it automatically, whatever present in your YAML file as part of your Docker compose file, your Docker will start running it, right? So you can deploy your whole application stack as a single entity with a single command. So that's where it makes your life very easier, right? So whatever demo we did using Docker run command, now we will do the same for Docker compose, right? So when I say the same thing, that means here I want to deploy the invoice app, the Postgres DB, and the Docker network together. I want to create a Docker network first and deploy all these 2 containers together on the Docker container. Start listening to invoice app on 7002 and Postgres DB on 5432, right? So now let's quickly go ahead and do so. Alright guys, so if you look here this file, right, so this is the same directory where I had the invoice service. Now I have created a docker compose.yml file, and if you go back to the presentation, this is why I said advantages of compose is you can define your application stack in a file, right? And also you can create a YAML file to define services with a single command. Alright guys, so here we have the docker compose file, right? So what we talked about earlier. So we have the services, then we have the network, we have the volumes, right? So these are our Docker objects. These are known as Docker objects, and we have already spoken about these things already, right? So now it's very simple. So whatever we were doing manually right here by running all these commands, right? Now we are simplifying things, keeping it together, consolidating. So whenever I run the docker compose up command, all these things will start executing in a ordered fashion, right? What would be the order? So let's say you have services the Postgres database, then you have the network, then you have the volumes, right? So these services are dependent on networks and volumes. So ideally, first these network will get created, then the volumes will get created, then this Postgres database will get invoked, and then later on this invoice app v2 service will get invoked, right? Now you see, now let's go through one by one. You will get to know the things, right? So in the Postgres DB, the container name will be Postgres DB, and here the invoice fv2 will be the container name. Image I'm referring is to use this image that already is present in my local, even in the fact that if you use any image that is not present in a local, it will automatically will try to find out from the Docker hub, which is public repository. I'm saying, okay, you expose the Docker container 5432 to the host type 5432. So whenever a request comes in and this port number, this request will be rerouted to the Postgres DB container. Same thing applies to the invoice as well. If any request comes to 7002, this will get rerouted to the invoice v2 container. Now there is a different case with Postgres database because we will have to persist the data. So I'm saying you persist the data to this volume. So in order to persist the data, store it, right, you need to create volume. So this is where we create the Postgres data volume. All right. And then we have the environment, because of the fact, if you remember here as well, we try setting up the environment variable for Postgres database. Same thing, we are passing the environment here. Now I don't have to see, using Docker Compose, I don't have to keep on running and using that boring, inefficient, time taking task of running manually command, right? That takes a lot of manual intervention. What I can do, I can simply keep every services right here, create networks, volume, and we are good to go, right? With one single command I can run the entire stack in one single command. Now if you go to networks, I'm attaching these two containers on the same network, which is your Docker demo network. All right, and this depends on a special key on invoice v2, because I'm saying that invoice fv2 is dependent on the Postgres DB. So whenever you invoke the Postgres DB, then only you invoke the invoice fv2. This is how you can interpret this, right? So what I'll do, let's give another name to Docker demo v2. I'll say Docker demo -1, and then you can see -1, right? So now let's update, let's create a new network, and then this would be -1. All right, so now everything will be same. Now what I'll do is I'll go here and then we'll run the Docker. So I'm already here, right here I have the Docker file, right? You see this Docker file I already have. I simply run. Now you need to be in the same directory where your Docker Compose is, right? So there are two options. Option one, you directly run the Docker up. So the life cycle of Docker Compose will get attached to the life cycle of container. Whenever I do Control C, so this will get stopped. This whole Docker Compose will get stopped. Another command the same way used to have in Docker run is -d. You run the Docker Compose in the detached mode, right? So either way, so let's try with the Docker Compose up, right? Very simple. Now you see it first created the Docker network, right? Then it created the volume, then it invoked the Postgres DB, then it invoked the invoice fv2, and you see my app is up and running, right? You can see my Tomcat application has been started, right? Same thing happened with the Docker run command as well. It's just that we are now controlling it using a single file. I didn't had to type in a lot many commands, 3-4 different commands in order to run all the containers, right? Now if you go back to the Postman API and then you try sending this, you will see you keep on getting data, right? You see this. All right, so now if I go to Docker desktop, right, in the Docker desktop you will see Docker demo. In the Docker demo, the Postgres DB1, there have to be, I'll remove this. All right, so you see in the Docker demo is my Docker Compose, right? If I click on it, you'll see I'll see the logs of entire Docker Compose. So the Docker Compose logs, that means it's a mixed logs of both containers, right? If I would have here 4 containers, then I would be seeing four logs, mixed logs of 4 different containers, right? Now I only want to look at the logs of invoice service. So what I could do is I'll go to invoice app v2, and you see here, right? So if I click on this API, you'll see logs are keep generating. That means whenever a request is being sent on 7002, this request is being routed to this invoice app v2 container, and then this is going to the database which is right here and deployed on the same network, these two containers, and fetching the data for a user ID, right? For which user ID? This user ID, right? So now this also conclude the whole architecture, right? This host, Docker, and then these running on the same Docker network, and this also has, by the way, a volume, right? Now, so now this way, if you see now how Docker Compose made our life so easier, right? You see that, you already saw that, right? Now let's say if I have 5 more applications, more containers, I don't have to keep on running it manually, right? What I could do is I could simply use the Docker Compose command in order to put on the entire stack, in order to deploy the entire stack with one single command, right? Now going forward, if you use Docker Swarm or anything for clustering, then you can use a single command to set up the entire infrastructure in terms of your application stack, right? So this marks the end of this lecture, guys. By this time we understood all the fundamentals, we understood why do you need Docker, right? We understood the architecture, the different Docker objects, Docker registry, Docker images, Docker containers, right? We understood Docker desktop, Docker hub, all these things we understood. We also understood how to create the Docker images and how this whole workflow gets invoked, what is the process of this whole workflow. We also did running all the practical examples, playing around all the Docker commands, and then we understood the Docker Compose as well, how it made our life very easier, right? So now let's meet in the next lecture. Thank you so much, guys. So now by this time you must know and should have a basic understanding of Dockers, right? This is what is enough to understand and appear through the entire course, right? And very soon you will see when we will create the services, we will be creating Docker file to create Docker images of the custom images for the services. There we have explained that in depth how it works, right? So this marks the end of this lecture, guys. Let's meet in the next one. Thank you so much.